to record. And then you can minimize that GoToMeeting control panel. You don't really need it up the whole time.
Okay.
You can see where the minimize button is maybe. And if you click on that, it takes up a lot less space on your desktop.
Okay.
Okay, hold on a minute. Let me see what I got here. All right, we're going to do some geometry tonight. When did you start back to school? You're in Douglas County, right?
No, Jefferson County. I go back to school. Basically our initiation is on Thursday,
Right.
and school technically starts on Friday.
Okay, cool. Yeah, that's what I'm hearing from other Jefferson County. I was wondering, do you know when Douglas County goes back? Do they go back the same time?
I don't know, actually.
Okay. No big deal. So. All right. Here's the way my drawing tablet works. In other words, whatever I write on this tablet, a squared plus b squared, you can see all that?
Yes.
Equals c squared. That's a right triangle where that's true. That being that
Pythagorean Theorem.
Exactly. One of the most important theorems you can get out of geometry is that Pythagoras Theorem. Okay, but we'll get to that later. What I'd kind of like to do today is go through some basic geometry questions. This isn't necessarily what they'll do when you start class. They may start you on proofs, but I'd like to really work on your geometry foundation. Let's get it built up strong so that when they do give you harder stuff, you'll be ready for it.
Okay.
The first thing that's key in geometry is this particular set of geometry problems I have are lines and angles, and then circles, and then triangles, and then solids, and so forth and so on. And it kind of progresses through each one of them. So if we look at this first problem here, you know what the value of x is? Can you figure it out?
Do those say x squared or x?
The value of x, that says x degrees is what that thing is above.
Oh, okay.
Okay.
Well, x equals 50.
Okay.
X would have to equal 50.
Good. Okay. I'm not going to spend a whole lot of time. If you know the answer, I'm just going to go through these really quick. So let's look at number 2. If you know x is 50 there, you know what you're doing. So let's go to the next one. What's the measure of AOE?
Okay. That would be 145 degrees.
Very good. Number 3, up here on the right. What is the sum of w plus x plus y plus z?
Okay. I know
What's the sum all the way around?
What?
What's the sum all the way around?
The sum is 360 degrees.
Okay. And there's one angle that they're giving us, and so they want the sum of the other 4. So what would it be?
Okay. Oh, the sum of the other 4 would be 330.
Good.
Wait, no, 300.
No, you're correct. 330. Oh, you're right. I didn't see that angle right there. Yeah, in other words, that angle. Can you see where my cursor is pointing here?
That angle is the same as 30 because
they're
basically across.
They're vertical angles. Those are called.
They're connected by the same 2 lines, meaning they, unless one line was curved, they would be the same angle.
Right. Okay.
They would
So that's 30, so we have 360 minus 60, so 300 is the sum of
Yes.
those other four angles. Okay, good. How about number 4? What's the value of x plus y?
X plus y is 90.
Okay. I'm going to have to get harder than basic for you.
Do they teach this in geometry?
Yes, they do at some
Oh, God.
but,
Do they teach this level?
well, they have kind of a strange curriculum in geometry that they use. They kind of start off with proofs. Now, you and I may get the proofs before you go to class, but probably not. In other words,
I already know what x equals number 5.
yeah, you're pretty good on this stuff, but we'll get harder.
It equals 30.
Okay, good. How about number 6?
In the figure above, EB is a perpendicular to FC, and AD and EB intersect at point F. What is the value of x? Okay. Wouldn't that be 30?
What's the value?
30.
What's those 3 angles have to total?
Oh, it'd be 50, sorry.
There you go. Hold on a minute, I got to figure out how to advance through these a little more efficiently. Yes. Works, I guess. Problem is more figuring out Windows 10 than it is. I just recently moved to Windows 10, so I'm a little unfamiliar with it. Okay, here, these are more intermediate questions, and this particular question, number 7, has to do with parallel lines and perpendicular lines. Okay, now notice what the graph is saying is that that angle is a 90-degree angle. So, and x is equal to y. So right off the get-go, what's x and
y are 90. X and y are 90.
Good, good. So now what has to be true? Let's look at these 3 propositions here. Does line 2 have to be parallel to line 3?
It doesn't have to. I'm gonna guess 3. Answer 3.
Okay, let's talk about parallel lines.
Oh, no, sorry, I was wrong, yeah.
Okay, no problem at all. I mean, you haven't had geometry yet, so I'm not really expecting you to know much of any of this. But if I have 2 parallel lines and a transversal, okay, this is one of the more common problems in geometry. And you signify parallel lines by those arrows there. You can see that we create 8 angles, right? But in reality, we only create 2 unique angles.
2 different angles, because 1 and 4 and 5 and 8 are the same, and 2 and 3 and 6 and 7 are the same.
Perfect. Okay. So, it works in reverse also. By that I mean if I draw 2 lines and I put a transversal there and I tell you that 1 is equal to 2, does that guarantee those lines are going to be parallel?
Yes.
It does. In other words, it works both ways. If you have those angles equal to one another, then
yep, I get that.
2 lines have to be parallel.
I get it now.
There's no way that angle 1 could be equal to angle 2 unless line A is equal to line, or is parallel to line B. Okay?
I'm just having trouble understanding the context of the question.
That's okay.
That trips Yeah, that trips me up most of the time.
Don't worry about that. Here, let me get back to where we were. And let's take a look at this problem again. Let me blow it up again. Okay, now, the fact that that angle, that right angle, is equal to x means that line 2 and line 3 have to be parallel.
Yes.
Because all those angles are equal to one another.
And line 1 and line 2 must be perpendicular.
Correct, and that's what that sign means. So number 2 is also true.
So any line that intersects line 1 also intersects line 2. No, that is not true, I don't think.
Correct, you're right, because I could draw another vertical line that intersects line 1 that was parallel with line 2, and parallel lines never intersect. So it'd be very easy to draw a vertical line that intersects with line 1 that doesn't intersect line 2. So 1 and 2 only. Okay. Number 8, a little trickier.
Okay, in the figure above, is that, yeah, V equals 2W.
Yes, V equals 2W, W equals 2X, X equals Y over 3. What's the value of Y?
Okay.
So tell me how we're going to go about solving this problem. Well, God, I hate Windows 10. That's probably enough of it for you to see so that I can still write over here.
Well, I don't know all those.
What equation can I start the problem off with? V plus what?
V plus
W plus X
plus Y
equals
180, sorry.
180. 180 is the magic number in geometry. In fact, I told your brother that there are few skills that are more useful in math than being able to subtract the number from 180.
I think I'm getting it now. You divide 180 by 2.
Well, let's start with this. And what we want to end up with is solving for y, right?
Yes.
Okay. So we kind of need to turn all these other variables into y, because we're not going to be able to solve that equation as long as there's 4 variables in it. If you only have one equation, then you only need one variable. Well, let's look at some of these other variables. Let's start from the back. What's x equal to?
It would be 3y.
Well, x is equal to y over 3.
Oh.
So I can substitute that for x. And let's back up. What's w equal to?
Would w equal?
It's 2x, right?
Yeah.
And x was y over 3, so w must be 2y over 3. You see what I'm doing? I'm wanting to get every variable in terms of y, and then I'm going to be able to solve for y very easily. Now, v is
and v
w.
would be 4y.
There you go. Multiply that by 2, you get 4y over 3. And now we have a simple algebra equation. And it's very important to understand that geometry is at least 50% algebra. In other words, what you do is you take these figures, you work out an equation, and then you solve it. But it's always an algebraic equation. Now, let's talk about solving this algebraic equation. What's the best way to solve that? What's the best next step?
Add all common terms, similar terms.
That's one way to do it, but it leaves you fractional. In other words, this is going to be 2y, and that's still going to be 1/3 y, and that's going to be 1y. Let me give you a simple technique when you're working with algebraic equations. Let's get rid of the denominator. What can I multiply both sides of the equation by to get rid of all denominators?
3, right?
Yeah. So what's this term become?
That would become 12y.
Well, 12y over 3, which is 4y.
Oh.
In other words, the reason we're multiplying both sides by 3 is to get rid of these denominators. Okay. Next term, when I multiply it by 3, becomes 2y. Next term becomes y, and this becomes 3y, because I have to multiply every term on the left side by 3, and every term on the right side. So that becomes 540. Now the problem, or the beauty is that now that's a very easy equation to solve. There's no fractions in it anymore. How many total y do I have?
Well, you have 10y.
So I got 10y equals 540. So
Y equals 54. Oh, okay.
And notice why that was easier than had we added up without multiplying by 3. Let's go back and do that just so you can see. It's a little harder. Anytime you have fractions, it's going to be a little harder. But if I add that and that, I have 2y. There's 3y. There's 3 1/3 y. So that's how many y I have, equals 180. Okay? Now I have to do some stuff. In other words, I got to turn that into an improper fraction. So that's 10/3 y equals 180. And now I multiply by 3 and divide by 10. So I get to the same answer. It's just I had to deal with fractions. So whenever you can eliminate fractions immediately, I would always advise doing so. It makes the problems so much easier. Now, it's not always a case of where it's the same denominator. In other words, maybe this was y over 6. And then I'd have to multiply everything by 6 to get rid of all the denominators in one step. Maybe it's a 7. Now what would I have to multiply everything by?
A common factor of those.
Which is what? What's the least?
21.
Exactly. So I would multiply that, each term by 21, and that would get rid of all the 3's and the 7. Makes a big number over here, but still is much simpler once you eliminate the fractions. So you always want to do that. And notice one thing else about this problem. I had to work from right to left. Right? If I worked from left to right, there's a lot more steps. Notice that V is 2W. And then W is 2x, and then x is y over 3, and then there's y. Well, now I still have a w and an x in the thing, and I got to go back and substitute some form of y. In other words, I need to get it down to one variable, and they're asking about y, so we want to get it in terms of y. So I would then have to convert that to some number of y, which we know is 2y over 3. And then I would have to convert that to some number of y. So it actually worked a lot better when I went right to left. We immediately were able to put everything in terms of y. And that was the key. All right. Hold on a minute. Number 9. I don't know if you can read all those letters, but it starts A, B, C, D going clockwise. A, B, C, D, E, F, G, H. Which of the following must be equal to 180? And look at each one. It's a plus b plus e plus h.
They all look around kind of the same degree.
I can't use that. On all these geometry problems, you can't use what it appears to be. Because they can make it appear that they're all the same. But you cannot assume that. What you can assume is that angle G is the same as angle C, correct?
Yes.
You know your vertical angles. And you can also assume that these are all straight lines. So I know that A plus B plus C plus D equals 180, correct?
Mm-hmm.
So how about A plus B plus E?
Okay, no.
E is the same as A.
A plus
H is the same as D. So number 1 is not necessarily true.
But B.
Okay, let's look at number 2. B plus E.
Well, but B's kind of opposite is F, so we know those two are the same, but not B and E or G or H.
The thing to notice here is that B plus C plus D plus E is equal to 180, correct?
Mm-hmm.
And now what they're saying is B plus E, well, G is the same as C, and H is the same as D. So these 4 angles also have to be 180. You see my reasoning?
So they are 180?
Yeah, in other words, B plus C plus D plus E is 180. Well, what we have here is B plus E, and then they stick in a G and an H, but I can see that G is the same as C, and I can see that H is the same as D. So what they're really saying is we have B plus C plus D plus E. So 2 is correct. Has to equal 180. Let's look at the third one. A plus B plus D plus
G.
Well, what's G the same as?
G is the same as C.
Okay, so it's 3 true.
And A plus B plus D would all, I think, I'm trying. I don't exactly know how to explain it, but I know it works.
Okay, you're correct. Let's label. Let's talk about it though. Here's what we know. We know that A plus B plus C plus D equals 180.
Equal 180.
Right.
And I got it now. And C and G are the same, so you could just substitute C for G and you get 180.
You got it. And that's exactly what they did. They rearranged the terms a little bit, but what they have is A plus B plus D plus G. So that also has to be 180.
Okay.
So 2 and 3 are true, but 1 is not necessarily true. In other words, you kind of have to get, the only way to know whether these things are 180 is if they make up the 4 angles that make up a straight line. And there's 3 different straight lines in this picture. So that's a little bit of a tricky one.
There are 4 different straight lines.
You're right. I miscounted. Okay, here again, parallel lines. Parallel lines are huge. If you get the concept of parallel lines, that's going to take you a long ways in geometry. Okay?
So maybe we should really start cracking down on that today.
Well, we'll get to them. As we go through some of these problems, we're going to encounter lots of problems with parallel lines. Let's talk about parallel lines for just a moment. A little bit more than we have. parallel lines are really easy if your transversal is at an angle. Because like you said, you only create two unique angles, and this one is acute and this one's obtuse. So all I have to figure out is this one's acute, so that's the same as 2. This one's obtuse, that's the same as 1. Okay? So it's really easy when it's like that. Where it's not so easy is if I do that. Or more precisely, if I make it much closer to a perpendicular line. Now, I've drawn a transversal, but I don't have a right angle sign here. So these don't all have to be 90-degree angles. In other words, one of that could be 89 and that could be 91 for all I know. Okay? So now tell me.
But then again, there are still only two unique angles.
You're right, there are, but I want you to tell me which ones are equal to each other.
Well, that would have to mean 1, 4, 5, and 8 are equal, and 2, 3, 6, and 7 are equal.
You got it. So
it works the same as with
vertical angle.
transversal.
Yeah, it does. It's when it's a transversal that's close to perpendicular, it's a little harder because you can't really see acute and obtuse angles, but you certainly know your vertical angles and you know your corresponding angles. In other words, that one's always the same as that one, regardless if it looks like it or not. And that one is vertical with 8, so like you said, 1, 4, 5
Unless
are always the same.
Unless the cube, sorry.
It's okay. Okay, and that's the biggest thing about transversals. Let me get this back to... Do you use Windows 10?
I don't know if it's Windows 10.
Just curious, just because I'm frequently faced with questions that I don't know how to answer. Not math questions, but Windows 10 questions. All right, let's look at number 10. All three of those horizontal lines are parallel. So what's the value of A plus B plus C plus D plus E?
You don't have one angle value, so you cannot determine it.
Well, what's the value of A plus B?
A plus what?
B.
A plus D is 180.
A plus B.
Oh no, I get it now. So it's 180, 260 plus. Wait, no. You can't exactly get it from the information given, I don't think.
You're good. That's good. You're correct. In other words, I know that A plus B is 180, right? And there's the acute one.
And C plus D is 180, but then E doesn't.
E could be in.
E isn't given, and you don't know what that other side, what that corresponding angle is.
If I change the direction of that line just a little, it changes E without changing A plus B plus C plus D. So clearly E can be changed without changing these other relationships, which means we cannot determine it. All right. Let me figure out the next one to go to here. Maybe if I do this. All right, this is advanced. Let me make sure that's where it will be. Hold on. Yeah. Okay. You're definitely ready for advanced. I don't give everybody the advanced one, but
Apparently, I'm not allowed to get into honors geometry without a recommendation from a teacher.
you're
Well,
kidding.
Miss Sund asked me if I wanted to go into geometry honors, and I said yes. I didn't realize that I would need her to sign a recommendation.
Does it have to be a teacher or can it be a tutor?
I think it has to be a teacher.
Okay.
But
Can you go
Possibly I
back?
could contact her.
Can you go back to your tutor or your teacher from last year and get her to sign for you to get in?
Or I could get her to email. I feel like they're just, both of them are just as credible because I can't forge things.
Yeah, that's correct. And you'll get an A in regular geometry, but you might get an A in honors geometry. There's a slight difference, but not a major difference.
The slight difference is in progression, and
they go a little deep. They go a little deeper in all the subjects. In other words, geometry is like anything else. You can go really deep. You can get college geometry that is beyond my ability to do some of those problems. But
honors goes deeper in progression, and they expect you to progress faster, but they also have a lot more homework, apparently.
Yes, they definitely go faster.
But I'm in honors English. That's confirmed, so.
Okay. Well, from what I've seen of your math skills, I think you would want to be in honors geometry, regardless of what teacher you get. So if I were you, I would definitely try to get that email from your teacher last year.
And he said if I can prove to them that I'm worthy of honors geometry within the first week or so, then I can go in.
Oh, you can jump up. Okay, even after you're in a regular class? I'll bet you can do it.
It's not a regular class. It's still advanced, but it's...
Okay. I'll bet you'll be able to do that. We'll see. I mean, this session's going to help. It'd be nice if we could get a couple of sessions in before. But what they're probably going to test you on is more your algebra ability, because you guys haven't had geometry yet. So they're not going to expect you to know a lot of geometry yet. Although you know quite a bit. So you apparently have had a good deal of geometry before now.
I learned it just throughout the years. I learned about all that angle stuff in 7th grade. We had that one problem about it on a test, and I didn't understand it. So I came in after school. I got a perfect on that test.
Yeah. No, and it's worth it. If you can get an A in honors geometry, it's worth you taking the honors because you get a higher grade point average by taking.
Does it give you a higher grade point average?
It does. And a regular A, I think, is worth 4, and an honors A is worth 5. So.
Okay, then I'm going for honors.
Yeah, definitely. No, there's definitely more credits to be earned. In other words, your maximum GPA is not 4.
My friend Dylan, who is going into Algebra 2, he said that it doesn't matter. Honors doesn't matter.
Well, I might be wrong, but I don't think so. Everybody I've talked to has told me that it affects your grade point. In other words, if you can get a B in honors, that's going to it's going to affect your grade point average in the same as if you got a C in regular geometry. The reverse. If you got a B in regular geometry, that's going to give you the same number of GPA points as a C in honors geometry. That's my understanding of it. I might be out of date a little bit. But what that means is that, I mean, if you got an A, say, in every single course and you weren't taking any honors courses, you'd have a 4.0, right? But if you were to take nothing but honors courses, I know that. But if you were to get an A in all honors courses, I believe your GPA would be 5.0. In other words, it would be a full point higher. But I understand where they don't offer honors in some subjects. I mean, they don't offer honors in gym class or PE or things like that.
And even if it doesn't do that, it still looks good on your record.
Yes, it does. And I do believe. In other words, I have the other situation also that I'm continually confronted with, and that is kids who start in honors and they can't really keep up with it, and so they end up dropping back to regular geometry. And it's a good decision for them because they would be getting like a D in honors geometry, and when they drop back to regular geometry, they're frequently able to get a B or an A. So for them, they're much better off in regular geometry in terms of their GPA.
What I heard is people who get, like, who normally get really bad grades in math somehow make it up into honors class, but they can't take it and they are moved back down.
Yes.
They then get A's in that normal class.
Right. And part of that, here's what happens, and this is, well, I've seen it over and over and over, so I know what happens, but the honors geometry goes faster than the regular. So by the time they drop out of the honors and they go back to the regular is going over all the material that they've already gone over recently. So they have a really easy time for like the first month. When you go from an honors back to a regular class, the first month you're pretty much repeating everything you just went through. So they really have an easy time for the first month when they go back to regular. And that's true whether you're talking geometry or algebra 2 or calculus or pre-calc or trig or any of the subjects. The moment you go from honors back to regular, for about a month you're in heaven because everything is a repeat. But that's not going to happen to you. I'm pretty confident that once you get in honors, you're going to stay in honors, math. Okay? So this question here, which is under their advanced section, so these are not going to be that easy. Let's have a look at these. These have to be.
I already know that situation 3 works.
Okay, let's start with 1. I take them in order. You go bottom to top, typically?
No, that caught my eye, apparently.
I see that, and you're right. It does work. Even though there are 3 kind of odd angles, they're all symmetrical about the x-axis. Yeah. So 3 works. Let's look at 1 now.
A plus B equals D and E, that would work.
For sure, they're vertical angles. You know, yes, this is what you were referring to before. 1 and 2 are vertical angles. 3 and 4 are vertical angles. And vertical angles are always equal. What's that?
Horizontal or vertical? Wouldn't 1 and 2 be horizontal, or am
They're called, the word vertical merely means, doesn't have anything to do with vertical or horizontal. It has to do with their cross from one another.
With their positions, yeah.
Their positions. A is vertical with B. And A is a linear pair with C. A linear pair you get whenever you have a straight line, you have another line that is another straight line. So A and B are called a linear pair, which means they're always supplemental, which means they always add to 180. Okay. All right, so let's go back to this one. So we can tell that 1 is true and 3 is true.
And I already falsified 2.
Yeah, it's pretty easy to see 2 is false just
from
the size of the angles. In other words, B and E are very tiny, and C and F are both very obtuse. So there's no way that when I add 2 big angles, they're going to equal the sum of 2 small angles. Now,
if it was maybe B and A equals C, then doesn't that work? Because they're linear?
Yeah. Let's take a look at 3 again here.
Oh.
This is the way the picture is drawn. the way I kind of like to do geometry, question is A plus C plus E equal to F plus B plus D? Well, you correctly surmise that they're equal, but you got to be a little careful here. You can't assume they're equal because they look equal.
No, I'm not.
Geometry.
I'm saying that A is equal, that A from the left side is equal to the D and the right side.
That's the way you do it. In other words, you do it algebraically. We know
yes.
that A is equal to D, and B is equal to E, and C is equal to F, so A plus C plus E has to be equal to B plus F plus D.
Mm-hmm.
All right. Okay, and the diagram above, AD is equal to BE, and they're both equal to 6. CD is equal to 3BC. If AE is equal to 8, then what's BC equal to? Well, let's draw a picture. Let's draw a picture and label it, because they've given us so much information that it's fairly easy to get confused on it. First of all, AE is equal to 8, starting at the bottom. AD is equal to BE. In other words, this distance is equal to this distance.
Yes.
Okay. And then CD is 3 times BC. So I didn't draw my picture anywhere near correct. I need to put the C closer to the B, like they do. So now this distance BC is 1/3 of CD. Okay.
So I'm beginning to have a start. So if the distance A and D equals 6, then the distance from D to E must equal 2.
Okay, good.
And
2 there.
If you realize that the distance from B to E is 6, then you must realize that the distance from A to B is 2. So therefore, the distance between B and D equals 4. And since C is 3 times further away from D, you can realize that it is the distance between BC is 1.
So you're saying BC is 1 and CD has to be 3 times BC. So that's 3, 1, and 2, which is equal to 6. Perfect. Very well.
Yay.
Very well done. That is not an easy problem.
It was fairly easy.
It was easy for you. But for most people, that is not an easy problem. There's so many different relationships that they kind of get lost. So that's great. Let's keep going.
According to the diagram above, which of the following must be?
Let's talk about next week, first of all. By next week, you're going to be in class and you'll have a book or they'll be giving you material. And starting next week, we're going to want to work on the material that you're working on in class, okay? And the only way we can do that is if you bring the material to the party. And with geometry, what that usually means is you have to take a picture of it, unless we have the same textbook. If we have the same textbook and you're working out of your textbook, then you can just tell me what page to open to and I'll be able to see what you're looking at. But barring that, you're going to need to take pictures with your camera of the material, send it to my email address before our session, then I can bring that up on my screen and we'll have the material. Okay. This material I have here is not from any geometry class. It's just what I've always considered a really good geometry primer. And that's all I'm trying to do today is give you a little bit of a primer on some geometry things. But I didn't start advanced enough because so far you've gotten every single one of them. But just know that starting next week, I'll want to shift and start working on stuff that you're working on. In other words, if you're doing algebra review, let's do algebra review. If you're doing proofs, let's do proofs. So whatever it is you're working on, make sure you get that material to me somehow, preferably before the session starts, but it doesn't take long to take a picture and send it. So if you wait till we start a session, it only takes a minute or two before you can take a picture and send it to my email address. But that's what we're going to want to do from now on. For today, you don't have that material yet, so this is the best thing we've got.
Yes.
All right, so let's look at 13.
I already know the answer.
Good.
It's 1, 2, and 3. So starting with 1, P equals X and Q equals Y. I actually got this by...
Hold on. Why do you know P equals X?
Well, I actually got this by doing the second one first. Because if you look at this, X, all three of those angles would have to equal 180. So,
hold on a second. Let me do something real quick. You looking at the diagram?
Yes.
I'm going to draw it a slightly different way. Now is P equal to X?
I'm beginning to see my mistake now.
Okay. In other words, you assumed that that was a 45-degree angle. But it doesn't say that it's a 45-degree angle. And this gets back to one of the principles of geometry where if you're examining a problem graphically, like I did here, and you can see that, wow, if I draw that angle slightly different, everything else is true. That's still a right angle, but P is definitely not equal to X. So by graphically altering it, that's what I'm trying to say, by graphically altering it and as the way you're looking at it, you can frequently disprove stuff like number 1.
And 3.
Correct. There's nothing here that says that X and Y are equal to 45 degrees. I can see it by altering the line. Now, how about...
I wasn't going visually. I thought I had some sort of proof, but I didn't.
Well, you were merely making the mistake of looking at the picture and assuming that they drew it perfectly accurately. In other words, that certainly looks like 45-degree angles.
And it could be.
It could be, but it's not necessarily. It doesn't must be true. Mm-hmm. However, how about number 2? Does X plus Y have to equal 90?
Yes, because otherwise it wouldn't equal 100.
Well, we know that this angle right here, can you see where I'm pointing now? Well, let me point to my diagram here. We know that's 90, right?
Mm-hmm.
Well, and we know that X plus Y plus 90 has to equal 180 because they make a linear triplet. Mm-hmm. So X plus Y would have to be 90 no matter how I draw. It doesn't matter if I draw the line like that or if I draw it like that or if I draw it like that. X plus Y is still always going to be equal to 90.
Mm-hmm.
Okay. And number 14. Now here's where you get to a point in geometry where your goal is always to write an equation and then solve it. Don't try to solve this without writing the equation, even if you can. And you're probably smart enough that you could figure out what X was. But I want you to do it the following way. Write an equation. What equation has to be true?
Do you want me to actually write an equation?
No, tell it to me. I'm going to... What's true about these two angles?
Well,
what are they equal to?
2x minus 20 in parentheses is equal to the vertical angle across.
Add 3x to it.
Yes.
And what's that equal to? That's a linear pair.
That's equal to 180.
That's the magic number again. And now we've got 5x minus 20 equals 180. 5x equals 200. X equals 40. That's the way you want to do all problems like this. As opposed to trial and error. In other words, I'm sure part of you went through and checked each of these angles, especially the smaller ones like 40, to see if they worked. And you would have instantly discovered that 40 works.
Okay.
But that's not the way to do it.
My brother is canceling his lesson because he's had a long day.
Okay, so he's not going to do his 6 o'clock?
Yeah.
That's fine.
Or
Nope.
was it 5 to...
Well, they had already moved it back to 6 because he was supposed to have band today.
Okay. Yeah, but
That's
he's
fine.
home now.
That's fine.
So.
If he wants to cancel, he can cancel. You're always welcome to cancel or change it to a different time or change it to a half-hour lesson. It's really kind of up to you and your dad as to how. Doesn't really matter to me one way or the other. So as long as I get advance notice, that's more important to me, is getting advance notice. I would prefer to have like 4 hours advance notice, but
Yeah.
even an hour is okay with me.
Okay.
What I don't like is when I get like 5 minutes advance notice. Because I could, if I get an hour or two, I can schedule somebody else in that session. And in fact, I have a girl who's going to schedule a session tonight, so I'll want to go in there and open that spot up. So thank you for telling me that. Okay, this is a good place to stop.
I do want to get this last question, though.
We did. 14.
Oh.
In other words, when we set it up as an equation and solved it, we got x equals 40. Okay.
Yeah.
Now, the other way that you might be inclined to solve this that I didn't want you to do, because you're not always going to have multiple choice. In other words, they might give you this problem without multiple choice and expect you to solve for x. But,
well, multiple choice hasn't exactly been helping. Hasn't really been doing much.
It would have helped here because maybe you would have tried 40 right off the get-go and you would have seen 120 plus 60 is 180. Bingo. I'd have the.
Well, now that I'm learning these methods, I can get past guess and check.
Yes. Even though, don't underrate guess and check. If you're taking like an ACT or an SAT test, guess and check is a tremendously valuable tool. You don't ever want to throw it out. But we're trying to teach you geometry, and it just happens that this material is multiple choice. You're not necessarily going to get multiple choice questions when you are in class.
I know.
So you have to
but
solve.
Really, I've been really only using the multiple choice answers to really check my answer.
Yeah.
If it's on there, then I know it's probably correct.
No, every problem we've encountered, we didn't really need the multiple choice aspect of any of them. You were able to actually solve all of them without multiple choice.
And I wouldn't have needed it with this either.
Right. No, I know. I think, let me just make sure. Yeah. And now, see, the next section is triangles. And there's all kinds of principles about triangles. And then the section after that is circles, and then quadrilaterals. And
what was this section?
The last section was lines and angles.
Okay.
Okay? And triangles, 180 is obviously the magic number for triangles also. In other words, the sum of the three angles that make up the interior add to 180. So that's the most important thing you can remember about triangles.
And triangles also, can you see my mouse at all?
I cannot. I have the ability to switch and make you the presenter, but even then I can't see your mouse because you don't have a drawing tablet. So
on that very first problem,
right?
You see 40?
Right?
Well, the other number on that other side of it, of that line, would have to be 140. Because it works with the same principle of 180.
Right. But here, as long as you're talking about it, let's talk about this problem. Hold on. The way I'm going to solve this first problem is I'm looking at this triangle right here. I want to solve this triangle. Because if I can figure out what that angle on the lower left is, that's x also. Well, if that's 40, that's 40. And if that's 60, that's 60. So now the triangle has a 40, a 60, and an unknown angle. What's the unknown angle?
What?
Okay, here. Let me...
Oh, yeah, no. A 40 and a 60, it'd have to be 80, right?
Right, and that makes x also 80.
Yeah.
In other words, we come up with x by solving this triangle.
I wasn't thinking there for a second.
Vertical angle. Once you get two angles of a triangle, it's easy to get the third.
Yeah.
Okay, that's a good
Do we use hypotenuses a lot in geometry?
Yes. Hypotenuse is only with a right triangle. Right triangles are a special breed. You'll spend a lot of time on right triangles. And the hypotenuse is always opposite the right angle.
And it's always the longest angle.
It's always
but isn't that
yes.
Isn't that how you can use Pythagorean Theorem?
Well, here's what the Pythagorean Theorem says. If that's side A, and that's side B, and that's side C, Pythagorean Theorem says
squared plus B squared must equal C squared.
Exactly. No matter what A and B are. A can be 1 and B can be 10. And C will still be the square root of 101.
Okay.
Okay? So, yeah, right triangles are huge, but all triangles are huge in terms of understanding geometry.
So, I wouldn't have known that if I had just gotten out of algebra. I didn't exactly know how to really apply the Pythagorean Theorem.
I wished we had another couple sessions before your class starts, because there's a lot of things, basic stuff I can teach you that will help you, although you're not going to have any problem with it. You don't need to necessarily get ahead of your class. By that,
all I need is enough.
I have some students that I like to keep ahead, because they have a hard time keeping up with it. So if I can get them ahead a little bit, then when the teacher goes over that material, they understand it easier. So that's the ideal way. But you're smart enough that I think you and I will be able to keep you where you're getting an A in the class by just staying on top of the material during the week that you're covering it. We won't need.
Yeah, I was a little bit troubled in algebra.
Get ahead, but if we can stay on top, mainly don't let yourself get behind. If you find yourself getting behind, that's when it's dangerous, because then it's very hard to get caught up.
Yeah.
Okay, Bolton, I will. The way this normally works is I don't call you for each session. I just text you the meeting ID number.
Okay.
In other words, next Tuesday at 4 o'clock, I will text you the meeting ID number, and you already have GoToMeeting on your computer now. You don't have to go to that website and download it again. You just double click on the icon, put in the meeting ID number, and we'll be in a meeting. And you don't have to change your audio setting. It'll now default to computer audio. So I will talk to you next Tuesday, but I will initiate that by merely texting you a 9-digit meeting ID number.
Okay.
Okay? All right. Have a good week. Talk to you next week.
All right. You too, sir.
Thank you. Bye-bye.